Salam. Today, we will be studying Chapter 3, 3.2, Class 11 Statistics, according to PTB syllabus. Today's lesson is all about arithmetic mean. It is one of the most commonly used type of average. Anyways, the arithmetic mean is calculated by adding up all the observations or dividing the sum by the total no of observations. It is abbreviated as A.M. Arithmetic mean has the same units as in original observations. Meaning, if all the observations are in meters, then of course, the arithmetic mean will also have the same unit, which is meters. Okay, so do you remember Lecture 1.1 in which we studied population and sample? If not, go check out that lecture first. Here in arithmetic mean we also subcategorize in population mean and sample mean. The population mean is denoted by mu, whereas, in sample mean we can use any variable but must have a bar on top, like x bar, y bar. Now, let's look into arithmetic mean for ungrouped data. For that, the population mean of n observations y1, y2, y3 till yn is defined as this. Mu equals to y1 plus y2 till yn over the total population, and remember, in population we use capital N and capital Y's, while in sample mean we use lowercase. Anyways, for sum of all the observations y1, y2 till yn we use summation and divided it by the total population. Hence using the formula summation y dividing by n. Similarly, the sample mean y bar of n observations y1, y2 till yn from a population is defined as this. Y bar equals to y1, y2 till yn divided by n, which the total sample. Next we write all the summed observations in form of summation, where n is the upper limit and it starts with the lower limit 1. And lastly we can use the formula summation y over n. See, here both the y and n are small letters. Next is arithmetic mean for grouped data. The data that is in form of tables. Arithmetic mean for grouped data is calculated by the following formula, which is y bar equals to f(a) y1 plus f(do) y2 till fn yn divided by f1 plus f2 plus f3 till fn. For all the summed observations we use summation, so here the final formula is summation fy over summation f. The only thing difference here from ungrouped data is that we use the corresponding frequencies of each observations to calculate the arithmetic mean. Here n is the number of total classes, y is the midpoint of class, and f denotes the corresponding frequency. Let's look at a simple real-life example of arithmetic mean for better understanding of the concept. Ali is a student who recorded temperature for 3 days, and these were his observations. To find the arithmetic mean of his observation, we first add all the observations. 28 plus 30 plus 32, which is equal to 90. And step 2, we divided by the number of total observations, which is 3, so 90 divided by 3 is 30. Hence the arithmetic mean of the 3-day temperature record is 30 degrees centigrade. Easy, isn't it? Now here is the twist. Ali accidentally wrote the wrong observation on the 3rd day, which was 35 instead. So to correct that, we need to do the following steps. First, we used the same formula as we used before, just to make sure that we calculated correctly according to the previous observation. Next, we modify the original formula as summation of y equals n multiple y bar, which is also equal to 90, which is the sum of all the previous observation. So, the corrected mean is calculated as 90 plus 35, which is the new observation, minus 32, which is the old observation. So the corrected mean is 93. Grouping error. It is assumed that each of the observations is equal to the midpoint of a class. This causes the value of AM to be a bit different for grouped data. This difference is called grouping error. Next is an important topic, which is properties of arithmetic mean. First property is the algebraic sum of deviations of observations from their mean is 0. i.e. for ungrouped data it is summation y minus y bar equals to 0. And for grouped it is summation f brackets y minus y bar. Here are the deviations through which we found these formulas. In ungrouped we see that the summation y minus y bar equals to summation y separately n minus n y bar. We know that y bar equals to summation y over n. So here we can just cancel out both the n's, leaving just the summation y. Hence when we subtract summation y minus summation y, it obviously leads to 0. For grouped data it is the same, only with the addition of frequency f. Next property. Sometimes it is desirable to calculate the combined mean of two or more sample means using the individual sample means and their sample sizes. It is calculated as this. Y bar subscript C equals to N1 Y1 plus N2 Y2 till Nk Yk divided by N1 plus N2 plus till Nk. Which when taken the summation turns into summation Ny bar over summation N, i.e. the total observations of all the sample means. For example, we need combined mean of two groups. It will be found by N1 Y1 bar jor N2 Y2 bar over N1 and N2. So remember, combined mean can be calculated of two or more groups. Third property is quite similar to the first. Here the sum of squares of the deviations of observations from their mean is minimum. Meaning that if we take the collective square of summation y minus y bar, it must be minimum. Here are the formulas we use when dealing with ungrouped and grouped data. Next property is that the mean is affected by the change of origin. If constant, a, is added to each of the observations y1, y2, till yn having mean y bar, then the mean increases by that constant. Meaning that by adding a to all the observations, we have a plus y1, a plus y2 till a plus yn. Then of course the mean would be a plus y bar. Similarly, if a is subtracted from each y, then the mean would be y bar minus a. For example, if a is equal to 10, then mean would be 10 plus y bar. Okay, the mean is also affected by the change of scale. If y1, y2, y3, till yn have mean y bar, then the mean after multiplying each observation by constant, a, is the mean multiplied by that constant. The mean of a y1, I2 till yn is calculated as y bar equals to y1 plus y2 plus till yn over the total number of observations. Next we take a common as a is multiplied by all y's. So all y's can equal to summation y here. In the third step you might notice that there is the formula of y bar which is sigma y over a, right? So we can write it exactly like that. So, hence after multiplying each observation by constant, a is the mean multiplied by that constant, i.e. I bar. Here is a simple and similar example as well. If a equals to 10, the mean would be 10 y bar. Let's move forward to arithmetic mean using shortcut method. Here the arithmetic mean can be calculated by these formulas. For ungrouped data, y bar equals to a plus sigma d over n, and for grouped, y bar equals to sigma fd over sigma f. Here the only difference is that instead of using n with is the total number of observation, we take the total frequencies of all the classes. You might be wondering what are these new variables d and a. D actually equals to y the observation minus a. And a is just an arbitrary value that can just be assumed. Here a and d also refers to provisional mean. Still confused a little? Let's understand the full deviation from how we got these formulas. First let's see for the ungrouped data, y bar equals to the arbitrary number plus simple formula sigma y over n. Next we placed that a n plus minus a with y plus minus. You ask? It is just to nullify the effect, and you might have learned this concept in mathematics. Okay, to after that we placed the a at its original location, and so the y bar equals to a plus summation y minus a over n. Now we know that d equals y minus a. Right, greater than, so hence we get this formula. Y bar equals to a plus summation d over n. The same concept is applied in grouped data as you can see. Hope you understood now. And if you did, please give this video a thumbs up. Next is the coding method. If the class intervals are equal, the arithmetic mean may also be calculated as y bar is equal to a plus summation foo over summation f, the total number of frequencies, and multiply by h. Here u equals to y minus a divided by h. And what is h? H is the common width of the classes. Common width means that all the classes have equal intervals. Now here is a visual representation of what we learned today. Now let's go through the merits of arithmetic mean. Merits are also called advantages. First, it is rigidly defined by mathematical formula. It is easy to calculate. It is easy to understand. It is based upon all the values. Number 5. It is stable statistic in repeated sampling experiments. Number 6. Sum of observations can be found if mean and no of observations are known. Next are the demerits of arithmetic mean. Number 1. It is very sensitive to any marked departure from the bell-shaped distribution and hence not suitable for skewed distributions. About skewed distribution we will learn in further lectures. Number 2. It gives fallacious and misleading conclusions when there is too much variation in data. Next, it is greatly affected by extreme value. And lastly, it cannot be calculated for open-end classes without assuming open ends. Weighted mean, the last topic of the day. In some situations, all observations are not of equal importance. To show their importance, we assign value called its weight. It is denoted by W bar and calculated as y bar subscript w equals to w1y1 plus w2y2 till wnyn divided by w1 plus w2 till wn, which equals to summation wy over summation w. That's all. Don't forget to subscribe.